Dave, when we're looking at Coca or Modi, I suppose we'd start off just by looking at a single line or an equation by itself. So in this case, I'm going to take an equation here that we'd see maybe in a cinema, which would be 2c plus 2p equals 6. And in this case, we'll take C as Coke and P as popcorn. So 2 Cokes plus 2 popcorns is €6. I guess when we're looking at these equations, we have to understand that when there's two variables, it's very difficult to figure out exactly what each is worth. So we know C might be worth 1, it might be worth 2, it might be worth 3, and maybe the popcorn is free. We don't really know. But what we can do is we can multiply that line across once we go the whole way across by any amount. So an example would be if we multiply it across by here, so if we multiply it across by 2, we get 4c plus 4p equals 12. So just everything multiplied by 2. Again, by 3 we get 6c plus 6p, so 6 Cokes and 6 popcorns would be €18. Again, down again, we'd expect for 8 Cokes and 8 popcorns to be €24, and so on. Okay, you could stay doing that forever. But again, it doesn't get us any closer to figuring out what one of each is, even though the values stay the same when we multiply them across like that. So that's when Coca or Modi or the simultaneous equations come in. Okay, underneath this little pouch here, I have another equation for somebody else who went into the same cinema, and they bought 5 Cokes and 2 popcorns, and they paid €9. So we can say now, we can write one equation on top of the other and try to see if there's any link between them. So when I went in, I got 2 Cokes plus 2 popcorns, and that was equal to my €6. And I can see I can compare the other one as well below. So we can do anything with these two. We can add them together, we can take them away from each other. Once we do something to one part of it, we have to do the same to all other parts to keep it the same. So in this case, I'm going to try, and we said if we have two variables, it's very hard to solve. So I'm going to try and get rid of one of the variables. And in this case, maybe I'm going to try and minus away my top line up here from the bottom line and see what I end up with. So I'm going to rewrite this out again, which is going to be 5c plus 2p equals 9. 2c plus 2p equals 6. And again, to take them away, I'm going to maybe multiply all this line by -1. So this will become a minus, this will become a minus, and this will become a minus as well. So again, I'm not changing the values at all. I'm just multiplying the whole line across by -1. And let's see what I get when I add them together now. So I'm going to get 3c plus 0p, which we can just negate altogether. It's going to be, it's no value, equals 9 minus 6 is 3. So in this case, 3c equals 3, so c equals 1. And that's all the difficult work done. Now we're going to pick the easiest line from, well, anything that we've got before to try and sub in 1 for c, and then c will be able to hopefully figure out what p is once I do that. So I'm going to take maybe this line up here, and I'm going to bring it across here. So I'm going to say 3 times something plus 2p equals 6. I know that's something, so it was, sorry, turboner, it was 2 times something. So I just took this line, brought it across here, and now for c I'm going to put in 1. So it'll be 2 times 1 is 2 plus 2p equals 6. So again, this line is the same, so 2 plus 2p equals 6. We're at the final stages now. I know some of us will work quite fast through this stage. So 2p is equal to 6. To get rid of my 2 here, I put a -2 over here. So we -2 on either side. So 2p equals 4, p equals 2. So now to solve this, I know a Coke was €1 and a popcorn was €2 to satisfy my both equations that I had starting off.